Okay, so we're going to go over these problems 1 through 4 and 9 and 10. You might notice on the top that it says like pre-calculus, right? So we're going to save 5 through 8 for actual pre-calculus next year. I hope to see most of you, maybe all of you there next year, but we'll see how that goes, right? So we're going to solve for y here on this one, and so what would you do for that? Move y to the other side?
Yeah, we can start by subtracting 6, or adding 6.
Add 6. Well,
Yeah, so you gotta get the...
yeah, you can do that. Now you could put it, now one thing you can do is this what you're suggesting, Ben? You go like this? Is that what you're talking about?
No, just the y.
Oh, just the y. So you're talking about going like this?
Yeah, and moving the x to the other side.
And so you're trying to do a double switch like this. So yeah, you can do that. Then you'll get like negative 3y, right? Equals negative x minus 6. That's what you get, right? Okay. Well, let's go. What we'll do is we'll kind of park this over here. We might address this later, but I'm going to kind of stick with Bryce now on this one. Okay. Let's go ahead and just kind of stick with Bryce. All right, Bryce. Okay, Bryce. I'm back with you again. What'd you say, Bryce?
Gotta add 6, right?
So now you have x, left side, x plus 6 equals 3y. So that's where you are so far, Bryce? Is that it? And I'm going to make one little suggestion here. I'm going to go ahead and rewrite this as 3y equals x plus 6. Now why would I do that? Yeah, and what it is these things are both the same, right? What property of algebra allows me to do this? You remember?
Right, wouldn't it be like reflective property or something, because one side equals the other?
Yeah, okay, very, very good. And what we call it is, he said, okay, Bryce said reflective property. It's actually symmetric property of algebra. No, symmetric property of equality. One side equals the other side. Does that sound right, Bryce? Yeah, and we had in 7th period, Jace came up with that too. All right, good job. All right, Bryce. Come on, Bryce. What do we do next?
Divide by 3. Divide 3 by 3, and then divide the whole other side.
3, right? So get y equals x over 3, and then what is this going to be?
2.
It's 2. And if you want to, you can write this as 1/3 x plus 2. Same thing. Okay? And anything else on this one? Okay, good. All right. So let's go to number 2. And someone, let's see, what would you do, Jay, or somebody, or Connor?
Subtracted 0.5. Right side, subtracted from both sides.
Subtracted 0.5y.
And then you subtract x from
So subtract x.
yes.
So we get negative 0.5y equals, we can write this as negative x plus 1. Is that what we can do?
And then
Okay.
you divide by half, or negative 1.
So negative 0.5. Okay, now really what happened is that Connor on this one, do you remember that Ben was taking us off in this direction? And Can you see that's what Connor's doing essentially? See that? Okay, so now, so we're kind of doing the way bent. So we have y equals, we got negative x divided by negative 0.5 plus 1 divided by negative 0.5. Does that sound right? So what do we have when we simplify this out here? Y equals 2x. And what would this be? Minus 2. Okay. Now, does anybody have trouble seeing that? Because I can see, as an experienced teacher of algebra, that this can be confusing for some people. Anybody confused by this?
Did you get the 2x because the x actually is like an actual 1 where the x is supposed to be? Yeah. Or where the x is? Okay.
Yeah. Okay, what I want to do is I want to back up because people aren't talking about it. I want to go ahead and show you something else that I think might make this a little simpler. What if instead we wrote this thing as x equals, this 0.5 is what in fractional form? 1/2 y plus 1. Okay? And otherwise, we did the same thing. We'd have negative 1/2 y and we subtracted the x. So we're going to get negative 1/2 y equals, right? 1, no, I'll put negative x plus 1. Do you see that this is the same thing as this? Or as this? Then, what can we do to this?
Multiply by 1/2.
Multiply by negative 2. Okay? So we multiply the left side and the right side, see the whole equation, by negative 2. What do we have? Y equals, what's negative 2 times negative x?
2.
2x, right? 2x minus 2.
Oh, yeah.
Right.
Okay, that makes sense.
Which ends up the same thing. So the main thing I'm just trying to show here is that sometimes,
There's different ways to do it.
yeah, different ways to do it, and sometimes a fraction is easier to work with than a decimal version, especially when you're dividing. Okay, that's the only thing I'm trying to bring out. So are we okay on that one? Yeah, let's go on to 3.
Can I try this one?
Yeah, go ahead. Help me out, Jade.
I haven't done it yet, so don't make, wait. Number 3, mine says plus 1.
Okay, I'm going to fix this one to be like yours, x. Because what happens on these is, like the ones on your sheet, I copy from the book, but in this case, this is actually from the book up here, and this is the mistranscription which shows up on your paper. So we're going to pretend that this is 1 instead, okay?
So the other ones, they started off with subtracting the y and the x. So I'm going to start off with subtracting the 1.
We'll subtract 1, okay?
Yeah.
So we have x minus 1 equals y squared, is that
Yeah,
right?
and then you subtract the x and the y. Like you switch the x and y by subtracting x on both that side and then y on the other side.
Well, I have a different idea. My idea is just to go ahead like this.
Oh yeah. On the
Right.
side, yeah.
Okay, that's fine. Okay, go
And
continue.
then would you square root the y squared to get rid of the squares? The 2?
So Jaden says he wants to square root the left side to make that just y. Does that sound like a good strategy?
Yeah. I did.
Merva?
I did. I
Okay,
did
good.
it. Oh.
Okay, good. So let's do that.
Yeah.
So now we have y is equal to square root of
X.
x minus 1. Is that right?
Yes.
Anybody else have anything to say about this? Okay, ladies and gentlemen of Algebra 2 honors, that is not a completely correct answer.
Right.
What's missing here?
I don't know.
Yeah, come on, Jaden. You said you got it.
Yeah, Jaden, this one's yours.
I said I might have it.
This is the same for the other, this is the same for the other classes.
Hey,
The one who finally figured this out in second period was,
Gabby?
no, sitting right there in second period. It was Rindy. It was Rindy. What was it that Rindy said after I prompted her to say that?
Hang on, let me text her. Hang
No,
on. You have to get rid of the square root, or the root.
Simplify it.
no.
You have to,
Okay, here's what's gonna happen, okay? Okay, Steve O'Finn, he was going like this, man, I'm gonna do this. Somebody, you guys, okay, get ready to do this. Yeah, that's right, Jay. Get ready to do this, the face palm, right? Ready to do that? Everybody ready to do that when I write this down?
I'm not ready.
You, Ben, are you ready to do that?
Yeah.
Yeah, okay, here we go.
Get your hand ready.
Wait, Ben, try. Wait. It's supposed to be 1 before the square root sign.
No,
It's supposed to be a 2 because you square root of the 2.
no, let me show you. What did you say, Riley? Okay. I don't know. Anybody have anything to add? Oh, here we go. I'm gonna show you what it is. I'll show you what it is here.
Oh yeah! I forgot about
Okay, now,
that.
Jay, did you do that? Okay, yeah.
Dang, I completely. What's that called though?
Yeah, okay.
I completely forgot about
Okay, Randy was our one who got that this morning, but I had to prompt her for it, okay? And then, okay. Now, when you were doing solving by square root method before, what was the type of problem you used to do with that? What kind of square root equation did you solve over and over again
like
last year?
this. Well, I don't know.
Okay, I'll give you a clue. There was this dude Pythagoras in 500 BC, master of philosophy, music, geometry, found you could take two sides of both sides of a rectangle. They'll be the square of a diagonal across any rectangle.
To find a triangle.
Pythagorean theorem.
Oh, dude, I thought it was that, but I just said it.
That's what I said. There was this dude Pythagoras in 500
Yeah, he said
BC.
Pythagoras, and I was like,
Pythagorean theorem, right? And so when you solve an unknown side using Pythagorean theorem, do you have to worry about plus or minus?
No,
No, why not? Why not, Connor?
because it's just not.
There's no such thing as a negative side.
So, yeah, so Ben just said no such thing as a negative side or negative distance, right? So that's why. And so when you've solved using square root method before, you haven't had to worry about this. But what happens is, if you have this equation, x squared equals 9, do you see if you solve by square root by both sides, you have x is equal to square root of 9, which is 3, but you understand, don't you, that this thing here could be either what? Could be plus or minus. And we're going to show why, because 3 squared is 9, but what else?
Negative.
Negative 3 squared is also 9. So that's why this one is here, okay?
I don't care, dude. I still set it up right.
Yeah, you did. No, you did a good job. I'm not being critical here, all right?
It's one. You,
No.
you meant to say you're stupid.
He's like, yeah.
Okay, audience on camera. That is Jaden putting words in my mouth incorrectly.
I know y'all heard him say that.
Can I say it for you?
All right, now this one here is going to be the same thing, right?
Yeah.
So you get y is going to be equal to plus or minus what?
Square root of x minus 6.
X plus 6, what
Ow.
you should get for it, right?
Good, that's easy.
You have to flip it.
Oh, yes.
Yeah. So anyway, that's what that is. So I'm just putting down the answer for that. And now we skip 5 through 8 and go on to 9 and 10.
Oh.
Okay.
Peyton's got this one. Peyton said he got this one.
Now,
Number
Already
5.
did it. You want the answer?
Yeah.
So what do you got, Peyton? What's your answer for this?
Oh.
He's holding the paper upside down.
I didn't get it.
You didn't get, anybody get this one?
Number 9.
What was confusing? How do you got, what was confusing about this one?
Riley, you got it.
The greater
There's two
than,
Y's.
no, the greater than has that comma and the y.
Yeah, okay. So this is the part that is sort of confusing to people. And I'm just going to explain, I hope briefly, that it shouldn't be that confusing. Okay, when you take the square root of something, what is the possibility of numbers you can take the square root of? What numbers can you take the square root of, or which numbers can you not take the square root of? Pardon me?
Whole numbers, correct?
Well, you can actually take the square root of fractions.
It's a column.
Can you take the square root of a negative number? Can't. Try to take in your calculator. Try to put,
No, it's gonna go up, right?
yeah, take the square root of a negative, like take the square root of -3 or something like that. What is that going to tell you? What'd you get, Addie?
Non-real.
Non-real number, right? Non-real number. So what happens is we can't have the real number that's square root of a negative number. Now, it can be an imaginary number, but we're not going there. We're talking about real numbers. 99.8% of the time in this class, we're talking about real numbers, okay? Now, so how do we adjust? How do we account for the inside of the square root not being negative? How do we do that? Well, I'll show you how.
I don't know.
What it is, we take what's inside the square root bracket, y plus 3, and we set this greater than or equal to 0. Right? And then when we solve for y, what do we get?
Y is greater or equal to -3.
Y is greater than or equal to -3. And so that's all this is saying. All this does is it worked it out for us and explained, okay, yeah, this equation is good, but let's be sure to remember that y has to be greater than or equal to -3.
So really we don't have to do anything on this question?
Well, then you have to solve for y still, right? You still need to solve for y.
So we can just use the y is greater than or equal to -3 instead of the square root?
No,
Because it's the same thing?
no. This tells you what y can or cannot be, right? But you still need to go over here and solve for y.
How do we do that? Oh, we have to do the square root to two things.
So how would you solve for y here?
Would you re-square, like put it to the power of 2? I don't know, to be honest.
What would you do? Riley,
Riley, you said something?
Addie, Bryce, Peyton, Gib. Square? Yes, do that. Let's go ahead.
I was about to say.
Let's go ahead and square here. And so if we square over here, what do we have to do over on this other side? Square, right? So what do we have now?
Y plus 3.
So we get y plus 3 equals x squared, and then
We're getting y, we have to do -3.
minus 3.
X squared minus 3. Okay, but Mr. G, you can't lie. I said that. I just said it really weird. I said you had to square root it, but like, I meant the other way.
Yeah, okay, yeah, I realize that. I realize that you knew what you're doing.
What's the other way called? What other way?
That's okay, that's,
What did you say? Yeah. What? I said that. He said you had to square it.
okay. So are we finished for at least the time being, giving Jaden a hard time? Okay. All right. And so this next one here, somebody else besides Jaden, what's going to happen on this one?
I'm on fire
I don't know
today.
what's the right answer.
So this one here, it's the same sort of thing, right?
Yeah.
So we just got the squared squared. So you get x squared equals y minus 2. So we got,
Finish.
so we get y equals x squared plus 2. And we know that whatever y is has to be greater than or equal to 2, right? Which is the condition they gave us at the beginning. But that's where that came from. Why? Because y minus 2 has to be greater than or equal to 0. So y therefore has to be greater than or equal to 2. Okay? All right, very good. What I want you to do is get ready to take notes on inverses of functions.
We don't turn this in?
Yeah, we'll turn
I
it
didn't
in.
finish 5, 6, 7, and 8.
No, we don't need 5, 6, 7, and 8.
Oh, okay.
We're saving those for next year.
Oh, please.
Our friends in pre-calculus are going to get those pretty soon. Okay, we're going to continue our discussion on inverses of functions from yesterday. And while you're getting your notes out, it asks the question, what is an inverse function? How do you know it's an inverse function? I'm going to ask another question. Does somebody remember something we talked about with regard to inverse functions yesterday? And it's not Ben. Ben was getting his teeth taken care of. What was one thing that you remember from inverse functions yesterday?
Two functions.
That was,
X and Y switch places.
Okay, now, so Gabby said something, Gabby said something, and then Jaden said X and Y switch places, and I want to take X and Y switch places. That's the one I want to focus on right now. Because that's gonna move us to the next thing we're looking at here. And and everything else, what Gabby was saying is related to that as well. But let's go ahead and just look at this. So, understanding inverse of functions. A relation is any pairing of elements of one domain with the second set range, so like an x and y. And so what an inverse relation does is it reverses the pairings of a relation. Okay, so what it does is it switches x and y. And then we talked about inverse function notation. You see this f negative 1 of x? You saw that in your notes someplace, right? Right at the top. And so we're going to go ahead and look at a mapping diagram. You've probably seen things like this in your algebra lifetime somewhere, right?
Yeah.
So here you have this original function over here on the left. And then we're asked the question, is this function one-to-one or many-to-one?
Is it 1 to 1?
It's going to be one-to-one because each input has only one output, right? So explain each input has only one possible output, right? Now, what I want to do next is get to what Jaden just mentioned a minute ago, and we're going to go ahead and fill the table out here on the right. How do we go ahead and fill in these blanks over here? What goes in?
Y switch.
So what goes over here in these blanks?
0 and 1.
Okay, 0 and 1. Does everybody agree with that? Okay, good. Now, is the inverse of this function also a function? So here's the inverse of this thing. Is this inverse also a function? Yes, no,
Yes,
maybe?
yes, it is.
Yes. And explain?
Because each input, only
Each-
one possible output.
Input
Has.
has only one, if I could spell.
Did you read? Out loud? Exactly, so you got the answer wrong, and I didn't. Dude, I got qualified for NHS, so you can just read through.
All right, let's go ahead, let's kind of stay on, as we'll try to go to the end. All right, now we have a different mapping diagram here, a different type of function. And so is this function here, the one on the left, is this a one-to-one or many-to-one?
Many to one.
No, this is a one-to-one
What?
because each input has only one possible output, right? So do you see that?
So if it was the other way,
Now, let's fill out this table here. So yes over here, I'm not going to write the detail. This one over here, what goes over here?
0 and 1.
Zero and
With that
one.
one's a many to one, right?
And this one here, the second one here, the inverse is not a function. And why not?
Because 2 goes to 1 inward.
Yeah, because two can go to either 1 or 4, right?
so if it's many to one, then it's not a function?
Right. But if it's 1 to many, it is a function.
So what it is, and if we went ahead and did this on like a XY coordinate plane, this is what it would look like, XY. We would have -2, -4 down here, right? So there'd be 1 point. But then we'd have -3, 0. But then we get over here to 2, and we would have what? We would either have this point here or this point here. So we have this point here, which is 2, 1, and right above it we have 2, 4, right? What's wrong with this? Fails the vertical line test.
Yeah.
Okay?
Props.
Very good. Good job. All right. So let's go over here to this exercise. We have this graph of the original function shown. And what do we do with this one to make an inverse?
Switch the x's and y's.
So we're going to do that, and because we're running out of time, I'm just going to kind of work through these really quickly. So 2, 1, and 1, 4. And then we enter all these here, -2, -4, right? There's one of the points, -3, 0. We have 2, 1, and then we have 1, 4 right up here. And what do you notice about these points here? They reflect about
Oh, they reflect the line?
the line Y. Now, remember one of the things I had you circle yesterday on your thing? Remember that? Okay, we're reflecting about the line Y equals X. Okay, the last thing we're going to look at today is this one right here. Okay, the 4-step process of finding inverses of functions. What I do is I switch the orders. Remember this 4-step process? Step 1, we call this one 2, we call this one 3, we call this one 4. And so we go over here and we have this situation worked out. We have step 1, we replace f of x with y. Step 2, that I say is step 2, we interchange x and y. That's step 2. So I'm going to go ahead and rewrite this as x equals 3y plus 4. You see that? So I just switched x and y. The next step is, that I'm calling step 3, that they call step 2, is solve for y. How do you solve for y? Well, subtract 4, so 3y equals x minus 4, and then divide by 3, we get y equals 1/3 x minus 4/3. And then last step is replace y with f -1 of x. So f -1 of x equals 1/3 x minus 4/3. So that's a 4-step process. Now, one last thing. We have just about 2 to 3 minutes of class left. I want you to go over here and quickly work out this your turn number 5. And when it comes down to wiping down your desks, we have Mr. Felix who will come and wipe down your desk after work. He does that, so we don't have to worry about it. Because we have Mr. Felix.
We're gonna turn these in.
Yeah, I'll come and pick them up while you're doing this. I want you to go ahead, Peyton, and see if you can work this out quickly. Okay? Are you making any headway on this?
Kind of.
Kind of. Well, in the interest of time, I'm seeing most of you working on this. I'm going to quickly wrap this up. So first, step 1 is change, right? So I'm going to write this as y equals negative 2x plus 3. Step 2 is switch x and y, right? So we get x equals negative 2y plus 3. What's the third step? Solve for y. So now we subtract 3. So we get negative 2y equals x minus 3. Then what? Divide by negative 2. So we get y is equal to negative 1/2 x plus 3 over 2. And then finally step 4, which is going to be f negative 1 of x equals negative 1/2 x plus 3/2, right? And so that's the 4-step process. And I hope you can see this was related to the exercise we started out with today.
Yeah.
Okay? So really, that's class today. I appreciate all of you staying with me to the very end today so we could get to this. I know it wasn't easy.